Does it mean exploration ends? Never. But it changes what exploration means. It means robotic probes, light sails, laser-driven micro spacecraft, like breakthrough Starshot gram-scale chips sent at 20% C, arriving in 20 years, sending back data via laser link before passing by at relativistic speeds. No landing, no return, just photographs. Data. Glimpses of worlds we will never walk on. It means accepting that we are this era's astronomers, watching from afar, cataloging distant suns, listening for whispers of intelligence we will never shake hands with. It means finding meaning here, in this solar system, on Mars, Europa, Titan, Enceladus, building sustainable civilization across 8 planets and billions of asteroids, becoming a multi-world species within our cage. Perhaps that is enough. Perhaps the universe allowed us consciousness precisely because it knew we would never escape, that our curiosity would burn brightest. When mendo impossibility, facing impossibility, are perhaps, just perhaps, Susskind is wrong somewhere. Perhaps the holographic principle hides a degree of freedom we haven't exploited. Perhaps quantum entanglement offers non-local connectivity we haven't learned to ride. But until then, until someone rewrites Maxwell's equations or discovers the error in Einstein's derivation, we are here, together, alone among the stars, forever reaching, eternally separated, always wondering. And that is the most beautiful tragedy the universe ever wrote. If you watch this feeling crushed, disappointed, or sad good, you finally understand the magnitude of the problem in ways pop science never explains. But do not despair entirely. While you are unlikely to visit Alpha Centauri personally, your grandchildren's grandchildren might receive a signal from a probe we launch in your lifetime. They might see images of exoplanets captured by light sails we designed today. Progress happens, just slower than movies promise. Now tell me, which barrier frustrates you the most? The speed limit? The fuel problem? Time dilation and lost family? Or the fact that even if we solved everything, space debris would kill us? Drop your answer below. And if this channel's blend of rigorous physics and existential dread resonated with you, if you want more content that respects your intelligence while destroying your optimism, subscribe, hit the bell. Join us next week when we ask, what if we are alone? Suggest yes. Thank you for traveling through the impossible with me today. Keep questioning reality. Even when reality says no. Class dismissed. Cancer probability approaches 100%. Unless your ship carries ridiculous amounts of hydrogen-rich shielding water, polyethylene, or generates magnetic fields, requiring nuclear reactors, adding more mass. Again, the rocket equation laughs at us. Finally, navigation at relativistic speeds. At 0, 1C, light from stars ahead, blue shifts to X-rays, stars behind redshift to radio darkness. Optical navigation fails. Radar, your signals return after months at target distances. Collision avoidance with objects traveling relative to you at fractions of C requires computing power and reaction times impossible for biological brains or current AI. Space is a shooting gallery, and you are moving through it fast enough to ensure fatal contact is statistical certainty. Now wait, I hear you scream. What about warp drives, wormholes, Alcubierre metrics, faster-than-light shortcuts through folded space-time? Barrier number 5. The universe forbids cheats. This is where Leonard Suskind's specific contributions matter. He didn't just study string theory. He proved the holographic principle with Hooft. He resolved the black hole information paradox. He knows the constraints of quantum gravity, and those constraints say no free lunch. Warp drives, Alcubierre drive. Miguel Alcubierre showed in 1994 that general relativity theoretically allows contracting space in front of a ship and expanding it behind, moving faster than light locally while respecting global causality. Sounds perfect. Problems discovered later. 1. Requires exotic matter with negative energy density. Does such matter exist? Casimir effect gives tiny negative pressure between plates, but macroscopic quantities, unknown. Quantum inequalities suggest negative energy cannot be sustained in the required configurations without violating uncertainty principles. 2. Hawking radiation inside the bubble destroys interior. The ship gets cooked by Unruh-like radiation during superluminary phase. 3. Upon arrival, destination gets obliterated. The bubble releases accumulated energy equivalent to many gigatons of TNT upon dropping out of warp. You don't land on a planet, you sterilize it. 4. Control issues. Creating horizon-like structures potentially allows time travel paradoxes, closed time-like curves, suggesting consistency, conditions, prevent formation, or destroy the vessel upon creation. Wormholes, Einstein-Rosen bridges. Traversable wormholes require matter-violating energy conditions. Average null energy condition. Need enormous negative energy to keep throat open against collapse. Quantum fields might allow microscopic ones briefly, but macroscopic traversable wormholes. Susskind and others argue stability requires fine-tuning. So precise it suggests impossibility, or hidden constraints preventing use, plus time machine paradoxes. If you move wormhole mouths apart, create time difference, can send messages backward chronologically. Grandfather paradox looms. Novikov consistency conjecture prevents paradox by making message creation impossible or irrelevant. Either way, no useful travel. Breakthrough propulsion, EM drive, etc. Violates conservation of momentum. Experiments show null results or experimental errors. Physics community unanimous, doesn't work. Would break Newtonian mechanics and QFT symmetry. Theoretical possibilities that violate known physics are not solutions. They are fantasy-wearing equations as costumes. Suskind's position, unless string theory or loop quantum gravity reveals a backdoor in the structure of Lorentz invariance, we haven't found unlikely given precision tests of relativity. We are geometrically imprisoned. The prison has no walls we can tunnel through. The guards are mathematical identities. The sentence, life imprisonment in soul system. So here we stand, or float, on a pale blue dot. surrounded by trillions of stars we can never touch, seas of darkness we can never sail, worlds that may harbor life we will never meet. The universe, through the elegant cruelty of general relativity and the harsh arithmetic of the rocket equation, has decided that civilizations like ours remain localized. We are not the masters of destiny. We are not destined for the cosmos. We are children sent to play in the backyard, told the ocean exists beyond the fence, but forbidden from swimming in it. Does this mean we stop looking up? Absolutely not. He pointed out that unless you discover anti-gravity, which violates the equivalence principle which he helped prove, or discover negative mass, which violates quantum field theory, energy conditions, we are trapped. The fuel required scales exponentially with desired delta V. Interstellar delta V is approximately infinite compared to our capabilities. We cannot carry the fuel, period. Suppose somehow through magic or alien technology you overcome the fuel problem. Suppose you have a drive that reaches 0.99c, 99%, light speed, without requiring infinite fuel. Barrier number 3, relativity will steal your life from everyone you love. This is the emotional barrier, the human cost that physics doesn't care about, but we should. When you travel at relativistic speeds, time dilation occurs. The formula involves square roots and fractions that approach zero, creating dramatic differences in experience time versus coordinate time. The twins paradox, identical twins. One stays on Earth, one travels to Proxima Centauri, 4.2, 4 light years away, at 0.86c, turns around, comes back. Earth twin ages 10 years. Traveling twin ages 5 years. 5 years lost forever. That is manageable, perhaps. A price worth paying? Maybe. But extend it to the TRAPPIST, one system 39 light years away at 0.95c, extremely fast, requiring impossible fuel. Travel there takes about 12 years for the astronaut, but 41 years pass on Earth. Round trip, 82 years on Earth, 24 years for traveler. Return to find your parents dead, your children older than you, your grandchildren, strangers. Civilization changed, technology advanced without you. Everyone moved on while you were frozen in relativistic time. This isn't tragedy porn. This is mathematics. The farther you go, the worse it gets. To reach the Andromeda Galaxy, 2.5 million light years, even at 0.99999c, fast enough to make the trip take only about 50 years of ship time. On Earth, 2.5 million years, humanity as a species has existed for 300,000 years. By the time you arrived in Andromeda and reported back, everyone who ever lived is dead. Evolution has continued. Humans, if we still exist, are unrecognizable. You are not an explorer returning home with stories. You are a ghost sending postcards to dust. Leonard Susskind emphasized this in his black hole lectures. Information preservation is key to physics. But information decayed by time dilation, lost to entropy, this is acceptable to the universe. unacceptable to human connection. Interstellar travel requires you to abandon everything, not for a few years, but essentially forever. You will never see anyone you love again. They will die while you remain young in transit, or age while you stay frozen, or simply exist in incompatible time frames. The universe enforces this separation through space-time geometry. It is not cruel, it is indifferent. But the effect is the same. But assume you have accepted loneliness, accepted the speed limit, somehow conjured impossible fuel, accepted relativistic divorce. Barrier number 4, space is not empty. And hitting things at 0, 1c, destroys everything. Space looks empty. It feels empty. It is not. Per cubic centimeter of interstellar medium, approximately 1 hydrogen atom, dust particles, silicate, and carbon grains. Micrometeoroids, larger than a grain of sand, rare but present. Cosmic ray particles moving at high velocities themselves. At normal orbital speeds, 8 kilometers per second for ISS, a paint chip causes craters. An astronaut hit by a fleck dies. Dangerous. Manageable with shielding. At 10% light speed, 30,000 kilometers per second, 3,750 times faster than orbital speed. Kinetic energy scales with velocity squared. Impacts carry millions of times more energy. Run the numbers. A single grain of sand, 1 milligram mass, hitting your ship at 0.1c releases kinetic energy equal to 67 kilograms of TNT, detonating instantly against your hull, not per hour, not per day. At these speeds, if you encounter 1 grain per meter of travel distance, a conservative estimate for dust density, every meter of your shield must withstand constant explosions. For a trip of 4 E16 meters, 4 light years, 4 E16 impacts of 67 kilograms TNT equivalent each. Constant, relentless, for 40 years. Shield thick enough? Lead shielding required for radiation anyway adds mass. Mass requires fuel, see barrier 2. More mass means harder acceleration, means longer exposure, time to radiation, which requires thicker shielding, which requires more fuel. Feedback loop of death. Then there is the radiation itself. Without Earth's magnetic field protecting us, interstellar space exposes travelers to galactic cosmic rays. High energy protons and nuclei that shred DNA at 0.1c. Relativistic aberration concentrates these rays coming from ahead, like driving into rain. They hit your front windshield hard. First, your mass increases to infinity. At 99% of light speed, your spaceship weighs 7 times normal. At 99.999%, it weighs hundreds of times more. To accelerate further requires infinite energy, which does not exist. Second, time slows down for you. This sounds cool until you realize what it means. If you travel to Proxima Centauri 4.24 light years away, at 99% of light speed, about 6 months passes for you. But on Earth, 6 years pass, everyone you knew is older, your children are grown, Your spouse might be dead, depending on how far you go. You aren't just traveling through space. You are traveling away from everyone you love, forward in time, never to return. Third, and this kills most sci-fi immediately, length contraction. From Earth's perspective, your ship shrinks. From your perspective, the distance shrinks. But crucially, neither observer sees the other, traveling faster than light. So let's run numbers for our nearest neighbor, Proxima Centauri, which has an Earth-like planet we desperately want to visit. At current spacecraft speeds, Voyager 1, 17 kilometers per second. Travel time equals 75,000 years. One way, with current chemical rockets, if we use the Saturn V engines from Apollo, still roughly 80,000 years to accelerate to decent speeds and decelerate at the other end. Even if we invented a nuclear engine tomorrow, still thousands of years to do it within a single human lifetime. Within 40 years of travel, you need to reach 10% of light speed minimum and the energy required to accelerate a small ship containing humans, life support, food, water, plus the fuel itself, plus the fuel to carry the fuel, which we will talk about later, is equivalent to detonating every nuclear weapon ever built simultaneously, and then doing it again every second of your journey. The universe put a speed sign on reality, and it says 299,792,458 meters per second maximum. Enforced by infinite energy requirements, we cannot cross it. We cannot cheat it. And that makes the stars effectively unreachable. But okay, let's say you accept the speed limit. Let's say we accept 10% of light speed, taking 43 years to reach Alpha Centauri. One way, surely we can just build a bigger engine, more fuel. This brings us to barrier number 2, the rocket equation, also known as the reason nothing leaves gravity wells easily. The Tsiolkovsky rocket equation is simple in form, but devastating in implication. Delta V equals exhaust velocity times natural log of mass ratio. What this means practically, every bit of velocity you need requires exponentially more fuel, and that fuel itself has mass, which means you need more fuel to lift that fuel, which needs more fuel. For that fuel, this is called the tyranny of the rocket equation. For Earth orbit, the ratio is manageable. For Mars, harder but doable. For Interstellar, let me give you the most frightening calculation in aerospace engineering. To send a 100-ton spaceship, roughly the mass of the International Space Station, to Proxima Centauri at 10% light speed, then slow down again when you arrive. You do not want to smash into the planet at relativistic speeds. You need fuel, a lot of fuel, using chemical rockets. Impractical, we will ignore it. Using nuclear thermal propulsion, still impossible. The mass ratio required exceeds the number of atoms in observable universe for anything beyond tiny probes. Using fusion engines, the best realistic near-future technology, current estimates suggest you would need roughly 1 billion tons of propellant. 1 billion tons for one small crude ship. For reference, the Great Pyramid of Giza weighs about 6 million tons, You would need 166 Great Pyramids worth of fuel. For comparison, all the oil humanity has ever pumped since 1850 totals maybe 300 to 400 billion barrels. A barrel is about 0.13 tons. Total to 50 billion tons of crude oil ever produced in human history. You would need 2% of all oil ever burned by civilization for one trip to the nearest star, one way. And here is where it gets worse. That billion-ton fuel number assumes perfect efficiency, assumes your engine converts mass to thrust at 100% rate, assumes zero structural weight for the tank holding the fuel. In reality, triple it, minimum. So 3 billion tons of fuel, 3 million kilograms. Just to visit our closest stellar neighbor. Who carries that fuel? Where do you store it? How do you prevent it from exploding? How much extra structure do you need to hold that mass? Every kilogram of structure needs fuel to push IT. Every kilogram of that fuel needs more fuel. It is a mathematical death spiral. Leonard Susskind himself discussed this in his lectures. I have some bad news for you. If you were planning on visiting another star system anytime soon, you might want to cancel your plans, because according to the laws that govern this universe, the very fabric of reality itself has made sure that we are stuck here, stuck in our cosmic backyard, stuck with just one Sunday, stuck with only 8 planets, and absolutely zero hope of ever leaving them for real. Now I know what you are thinking. But wait, what about Star Trek? What about warp drives? What about Elon Musk? What about colonization? Here is the brutal truth. Leonard Susskind, one of the greatest theoretical physicists alive, the man who fought Stephen Hawking and won, the father of string theory and holographic principle, has spent his entire career studying the fundamental structure of reality, and when he looks at the equations that govern our universe, when he stares at the mathematics of space-time itself, he sees something terrifying. He sees cosmic speed limits written into existence, energy barriers so massive they break physics, distance scales so absurd they make human achievement look pathetic, and time distortions so extreme they would tear families apart forever. The universe did not evolve to be explored by beings like us. It was designed or emerged with rules specifically tailored to keep civilizations isolated from each other forever. We are prisoners of geometry, hostages of thermodynamics, locked in a cage made of light speed limits and fuel requirements that would require us to burn every atom of matter in existence just to reach the nearest star at reasonable speeds. Today I am going to explain exactly why, not using science fiction, not using hope, but using the actual unbreakable mathematics that Leonard Susskind and physicists around the world have confirmed over and over again. And I am sorry to tell you, the answer is not optimistic. In fact, it is almost completely hopeless. Welcome to the most depressing episode of this channel. Humanity has dreamed of the stars since we first looked up. From ancient myths about gods riding chariots across the sky, to Jules Verne shooting men to the moon, to Star Trek promising to boldly go where no one has gone before, we have convinced ourselves that it is inevitable that technology solves all problems, that if we can imagine it, we can build it. But here is what nobody told you about imagination. Imagination doesn't care about E equals mc squared. Science fiction doesn't worry about fuel mass ratios. TV shows don't calculate relativistic time dilation effects on loved ones left behind. Real physics does. And real physics is cruel. There are 5 insurmountable barriers standing between us and the stars. 5 walls that the universe built into its foundation. By the end of this video, you will understand why even the most optimistic scientists admit interstellar travel is not just difficult. It is almost certainly impossible. Not because we aren't smart enough, not because we lack resources, but because the universe won't allow it. Let us begin with the barrier everyone knows about, but almost nobody actually understands. Barrier number 1, the cosmic speed limit. You have heard of it, the speed of light, 186,000 miles per second. Most people think, okay, we just need to get close to it, 99% of light speed. That should work, right? No, it won't. And here is why in terms you have never heard explained properly. In 1905, Einstein published Special Relativity. It contains 2 rules that destroy interstellar travel entirely. Rule 1, nothing with mass can ever reach or exceed the speed of light. This isn't about engineering. This isn't about better rocket fuel. This is baked into the geometry of space and time themselves. Think of it this way. The speed of light isn't a speed limit like 65 miles per hour on a highway. You can't just pay a ticket and go faster. The speed of light is more like the maximum angle possible in a triangle. You cannot have a triangle with 3 right angles in flat space. Not because you aren't trying hard enough, but because mathematics prohibits it. Similarly, you cannot travel faster than light because the relationship between space and time breaks down if you try. As you approach light speed, 3 horrifying things happen.